Okay, let's pick up where we left off with this drilling fluid, 1,600-pound batch. Because we have some ingredients that are denominated in gallons as amounts, and others pounds, kilograms, and parts each, of course. We all of the calculations for ingredients and the batch itself are actually done in units of weight. So because we have some units that are volumetric and some that are weight-based, we have to make sure that we have accurate conversions between the volume and the weight. And so I'm going to look first at the diesel fuel. If we scroll over a little bit, you'll see there's a column called physical. I'm going to widen it a little bit here, and I'm also going to make this 2 lines tall now by dragging the slider here. You notice for diesel fuel, it's using the program defaults for a specific gravity, so I don't really want that. I want to know what a density or specific gravity for diesel fuel is. So I'm going to go down here to the research menu, and you can see under research there are agencies that are like government agencies that have information, government lists, NGOs, non-governmental organizations, and then companies down at the bottom. I'm just going to do a Google search, and because I have diesel fuel highlighted in the list, it's going to ask to find ingredient diesel fuel. So I'll say go ahead and find ingredient, and over here in the I think I've got Firefox up here. Oh no, it's on Google Chrome. So it's bringing up some information on diesel, and you can probably see if you look down through here, there's some EPA listings, safety data sheets. I'm going to sort of cut to the chase, and instead of this, I'm just going to say diesel density, diesel fuel density. Hit a return, and it's coming up with 0.832 kilograms per liter. So back in my program, I'm going to right click on that line for diesel fuel and select set density or specific gravity, and physical state is a liquid, and the density was 0.832. Is that right? Yeah, 0.832 kilograms per liter. So 0.832 kilograms per liter, and say update. And now you see it's got 0.83, it's rounding. Okay, so barium sulfate, we want to know a density there because it's also using a default. You see that? So I'm going to go back here and say barium sulfate, and it's coming up with 4.5 grams per centimeter. So under barium sulfate, right click, set density, and excuse me, 4.5 grams per centimeter. Also, you notice here, because this is a powder, I'm also going to look for the bulk density. It's also saying 4.56, although, oh no, those are different things. Excuse me. So I'm going to put that in also because we're probably going to get it as a powder. So I'm clicking the divided solids button, and then I'm going to say 4.5 grams per centimeter, same as the density. Update it. And calcium carbonate, we also have a default situation. So calcium carbonate, go for the density first. It says 2.71. grams per cubic centimeter. And I'm also asked for the bulk density while we're at it. And let's see, I'm not coming up with, let's get rid of that powder. Calcium carbonate bulk density, see if we get something. I can't see it without digging around. I don't want to waste time. So I do have my own chart that, well, it's not my chart, but I download it from somewhere on the internet for bulk densities. And I get 44, and that's in pounds per square foot. So here, we want it in grams per cubic centimeter, so I'm going to put it, the one that I have is, what was it? Calcium carbonate, 0.7 is what they have for, but if we wanted to convert it, if we just had the 44, what we could do is pounds per square foot here. This is like a conversion thing. 44, and there's our 2.7, 0.7, I'm sorry. Okay, so let's update for that one. And calcium chloride is the next one. Okay, so it's 0.96 for the bulk. That's 0.96. Is that right, or did I mess up here? Calcium chloride, 0.96. Okay, and now I'm also going to look for the calcium chloride density, 2.15. So grams per cubic centimeter, update that. And calcium hydroxide is our next one. Move this up a little further. Let's see, we're still using a default there. You see that? SG default is 1. So let's do a calcium hydroxide density. .21. And that's grams per cubic centimeter. Okay, and this one's probably going to be a powder too, so and I don't want to dig around. I'm going to go back to my bulk density chart. Calcium hydroxide. It looks like 0.64 grams per centimeter. Okay, I'm going to update that one. And we also have a default here on silica. So silica density I'm going to do. Now what happened? 2.65. These are just rough for now. And this is going to be a powder also. So let's see what the bulk density of silica is going to be. Oh, there are lots of silicas here. I'm just going to use silica sand. You see that? At 1.3. The bulk density is for, the recipe itself. If you happen to be dispensing it in volumetric units, you wouldn't actually need it if you were weighing it out in pounds or kilograms. Okay, so we've got all these units in here, and if you notice, our batch size has changed. It's gone down to about 1,500 pounds from 1,600, and our number of containers is now 35. So 40 is still good here for, remember I put in 40 containers. Another thing though to keep in mind is because we are selling it in gallons, we probably also want to put in a more accurate density for our product itself. So at the bottom here from all of the ingredients, it's calculated about 12 pounds per gallon. So I'll put that 11.84 into the batch itself. So this is what we call the links menu, and it kind of relates to the the actual product itself in the substances section. You notice it says default right now. So we're going to go to it and change the substance density, and we're going to make it that, what was it again? 11.84. So, let's see. and that was pounds per gallon. There we go. Make sure you don't choose imperial unless you really mean it. That's pounds per gallon imperial and pounds per gallon. Okay, so update that. So our batch price is now $1,900 for all the parts. Excuse the ingredients. Let's give it a 2% shrinkage on the batch size. And the parts, those 40 containers, the jugs are $436. Let's give it a markup of 15%. Also, I'm going to put in some labor here. This is just illustration. You're going to have a lot more probably in yours. So let's just say clean batch area, clean preparation area. And let's make that, you notice I switched tabs. We were on items, now we're on instructions. I forgot to mention that. So let's say it takes 2 hours to clean the area, $15 an hour for the worker. Now I'm going to add in clean stirring vessel with distilled water and wait 1 hour to dry. Seems like a little bit excessive, but we'll do it. So that's 1 hour. And let's say he stays there the whole time. You wouldn't expect him to, but the worker, let's just say he does. Okay, so now if we look at the bottom here, those are our ingredient price, $1,900, shrinkage, parts. Now we got $45 of labor. So it ends up being about a $2,800 price list per batch and $113 per container. All right, I'm going to save it again. I did a Control S this time. Thanks for listening. I'll cover some other details in the next video.